As part of the Princeton research portion of the cloud computing workshop, I'm going to be talking about a little bit of ongoing work that Ed and I have been working on. To give an outline of the talk, there are going to be basically two portions. The first part is we've been collecting information inside the cloud to try to estimate web traffic to a bunch of different political websites. And by estimating these rates, the second part of the talk, I'll go into a little bit of detail about what we can do with this data set that we've been gathering in terms of analyzing trends for the upcoming election season. So first, just a little bit about analyzing web traffic. So far in this conference, we've been talking a little bit about the dichotomy between the server side and the client side when talking about cloud computing. A lot of the data is moving from the client to the server. And we see this dichotomy as well when looking at web traffic. So on the server side, if you want to analyze your own web traffic, if you own this particular website, you could look at your web server's access log and look at exactly which users have been going to your site, which exact pages they've been looking at. If you're very interested in what your traffic looks like, you can put little snippets of JavaScript on each individual page through Google Analytics, and it'll give you a lot more detailed information about your traffic. And a lot of people with larger websites use this to try to optimize their AdWords revenue. On the flip side, on the client side, there have been companies that have been trying to analyze web traffic as a third party. So there's Alexa, which is a subsidiary of Amazon.com, and also NetRatings, which is the internet arm of Nielsen, the traffic marketing firm. And what they basically do to try to analyze web traffic is essentially to have people download browser plugins, or what they call panels. And these users will install this panel on their web browser, and it will essentially send all their web traffic to the mothership, and then they'll process all the data. And I think they have something like tens of thousands of people doing this. I don't know why anyone would do this, because in terms of privacy, I know a lot of people here are privacy fiends. Why you would want to do that, but apparently a lot of people do. It's sort of a self-selecting process, too, in terms of who actually installs these panels. But anyway, that's how you might want to analyze traffic from the client side, and you could do this for basically whatever domain you want. But there's sort of a third way that to analyze web traffic, which is what we're doing, is we're really looking for information in this cloud area in between the server and the client, the data that's actually in the network itself. And in particular, we're looking at network data in DNS caches to try to make these estimates about web traffic. So to give a little bit of background about what DNS is, you might have heard of it before. DNS is the domain name system, and what it does is it translates human-friendly host names, such as sports.yahoo.com, into machine-readable and routable IP addresses, network addresses, such as 69.147.120.31. So basically what happens is when you type sports.yahoo.com into the location bar of your browser, your computer in your browser doesn't actually know how to fetch that page. What it will do is it's going to consult a local DNS resolver or cache and essentially uses it as a phone book to make this translation between this host name and the IP address. And once this resolver returns back this machine-readable IP address, it can actually route to that IP address and fetch the page. So going into a little bit more detail about how DNS works. On the bottom right here is a laptop, say in this room, and you're getting a little bit bored of my talk already, so you want to see what happened in the world of sports yesterday. So you're going to type sports.yahoo.com into your location bar. And since everyone here in this room is on PU Visitor, the wireless network in this room, it's going to know about the Princeton DNS resolver, and it's automatically going to send a DNS query to the local resolver and try to get this translation. What the resolver will do, it will first look in its cache, and if the translation is in its cache, it's going to return the answer immediately. But since, let's say, it's not in the cache yet, what the resolver will do is it's going to send recursive queries into the cloud itself. I'm going to gloss over some of the DNS details here, but it's going to eventually locate the name server for Yahoo and get the IP address from, basically get the authoritative answer for sports.yahoo.com and return it back to the resolver. What the resolver will then do is it's going to remember this mapping between host name to IP address for some length of time, and eventually it's going to forget about it. But before it forgets about it, the cache is going to return the answer back to the user. Now, a short time later, if somebody else in this room, also starting to get bored of this talk, wants to go to sports.yahoo.com, and this entry is still in the cache, then the resolver doesn't need to go out into the cloud and to retrieve this information from the Yahoo name server again. It can just return this answer directly. So a little bit more about DNS caches. There's 3 important things that you need to know about caches when listening to this talk. The first is that DNS caches are often shared by a set of local users. So for example, everyone in this room using this wireless network will be sharing one or a small subset of DNS servers set up by Princeton OIT, set up by the university, that will be using these small set of servers as the the directories for lookup. Also, these DNS caches are often geographically placed. So since you're sitting in Princeton, you're going to be using the DNS cache in Princeton. If you're using some residential broadband, there's probably going to be a DNS cache in your city or very close by. And the reason to do this is to make your browsing experience faster, because you always have to do this translation. You want this to be fast before you actually go fetch the page. The third aspect of DNS caches that's important is that many of these resolvers are left open to non-local users. And what this means is that even if I'm not at Princeton University, it might be possible, if the Princeton DNS server is open, for somebody else, say sitting in New York City, to look into this cache and to look into the contents of the cache and what sites people at Princeton have currently been looking at as a set of users. So I don't think that Princeton's actually doing this, but we have a list of about 1.2 million DNS servers located in the US, and I'd say about 15 to 20% of those are publicly accessible and open. So looking at, taking advantage of the fact that a lot of these servers are open, there's a technique called DNS cache snooping, which is what we take advantage of when trying to estimate web traffic. So, for example, let's take one of these open caches. Verio, which is a commercial ISP, has a DNS resolver sitting in Dallas, Texas. And there are a lot of local users in Dallas who are using this particular resolver. And they're going to a bunch of different websites. Let's say one of the local users has gone to sports.yahoo.com recently, so that entry is sitting in the cache, and the mapping is there. I, as a snooper sitting in Princeton, can basically peek into this cache and see that somebody in Dallas, Texas, using this particular DNS cache has recently visited that website. And so the cache will tell me that it knows the address. But what happens if I ask this remote cache and it doesn't have the answer? Before, what I told you in the way how the DNS resolver works is that if it's not in the cache will go out into the cloud to the Yahoo name server and fetch the answer, put it in the cache, then give the answer back to me. But when we're doing the snooping technique, we don't want to poison this cache with our own DNS queries. We don't want to put sports.yahoo.com into it. We just want to peek into it to see whether or not it's there. So what we need to do is send with our DNS query a flag that says, don't recurse, don't go off and go get the answer. If it's not there, just respond with a not in cache message. And because of the way that DNS works, we're able to send these do not recurse type DNS queries to actually just peek into the cache and not actually impact the things that are inside it. So in the view of a particular domain inside one particular DNS cache, we'll look at what exactly happens to the cache entry. So time moves here from left to right. And initially, no one has visited the site, so the entry is not in the cache. So this is the whole blue region. And we know that once a particular person using this resolver hits the cache, what the DNS cache is going to do, it's going to go find this IP address from the name server and bring that entry into the cache for some specified amount of time. Let's say, in this example, 30 seconds. And during these 30 seconds, if somebody else comes and hits the site, the resolver won't need to go off and do this translation again. It can just return the answer. But it doesn't lengthen the time that this particular entry is in the cache for. It will still sit there for 30 seconds from the initial hit and then eventually drop out. Then after it drops out, there's going to be some period of time where, again, this entry is not in the cache. And at the end of this period, there's going to be a cache hit, or there's going to be a site hit, and it's going to go off and bring that entry back in the cache. So we get this transition of out of cache, in cache, out of cache, in cache. And if we're snooping on this particular DNS cache, we can measure these intervals of out of cache, in cache times. And so estimate the actual hit rate. Oh, sorry about that. To estimate the actual hit rate, which is going to be in the units of hits over time, what we want to do is we want to find out exactly how many hits there were over the amount of time that we have. In the sections that are red, we actually don't know exactly what's happening. So for example, if these two web hits come during this red interval where it's in the cache, it doesn't actually affect the transitions. It doesn't actually change when the site goes in and out of the cache. But what we do know is that during the periods where it's blue and where it's out of the cache, there are no web hits until the very last instant when there's a hit that ends that period. So we know that during that each blue section, there are no web hits to that particular domain from any user using that particular resolver. So what we're going to do is we're going to basically drop off all these red sections and concatenate all the blue sections together. And so we'll get this continuum where we basically have 3 site hits over this interval of time, which is blue. And we know that during all the other times, there are no site hits. So we can basically estimate a hit rate this way, where we have 3 site hits over this period of time, and that's going to be our estimated rate. An alternate way of thinking about this is we're basically trying to find the average out time of a particular site. We're basically trying to find the average interval in between hits while the site is out of cache. And by taking the inverse of that average interval, we get the estimated hit rate. So to sum up, basically, the methodology. The things that we can track are particular domains and subdomains. We can track Princeton.edu. We can track citp.princeton.edu, the webpage for our center, because these entries will appear in the cache itself. But what we can't track would be individual pages. For example, princeton.edu/main/news. This particular page off the princeton.edu domain we can't track because that information isn't available using our method. Additionally, we can track sets of geographically clustered users. So we're looking at a particular cache that's shared by a set of users sitting in a that are geographically proximate to that cache itself. For you privacy fiends out there, we can't track individual users. We can't target a particular individual and look at the traffic, look at the web traffic for that particular individual. We can only get this sort of set. We can only estimate the web traffic from a set of users. So, using this method, what are we doing? We've set up this data collecting infrastructure, and we're snooping on about 50,000 caches, public caches in the United States. And each of these caches are tracking the same 250 domains. And in order to do all this legwork, we've enlisted a bunch of machines on Planet Lab to do all these queries and to basically get the measurements of when a particular site goes in and out of each of these caches. And so what domains are we interested in? So we think it's an interesting application. We're applying this method for the upcoming 2008 election cycle to try to analyze trends in terms of the candidates, in terms of media usage, and other metrics to just try to find interesting results that we otherwise wouldn't know. So what kinds of sites and domains are we looking at? So we're tracking all the major candidate websites. This is the splash page for BarackObama.com. We can also track the contribution site for Hillary Clinton because her domain is contribute.hillaryclinton.com. So note that if she set up her website in such a way that her donation page was at hillaryclinton.com/contribute.html, there's no way we can track this. But because of the way that this is set up, we could track these particular actions on the candidate websites. Other things that we're tracking, this scary man on the NRA website. We're tracking a bunch of different special interest groups and advocacy groups. Also, the New York Times, which is mainstream media, we're tracking the online presence of the top 100 local newspapers in the United States, as well as the websites for the major television news sites, the NBCs, the ABCs. We're tracking a lot of the news magazines, the New Yorker, the Economist, and also radio sites such as NPR.org. We're also looking at new media sites. We're tracking Daily Kos, which is a liberal blog. We're also looking at conservative blogs as well, redstate.com, Powerline blog, and also some more neutral political sites, such as The Politico, which is sort of a Beltway election news headquarters type of site. Other things that we're tracking, demographic information. We're tracking the top 10 Spanish language sites on the internet. Also, things that we might find interesting, like Comedy Central, to see whether people are interested in maybe the Colbert Report or The Daily Show. And also, we're tracking a lot of the major popular sites as a control, basically the most popular sites on the internet, on the web. All right. So, using this data, what we've done is for each of the candidate websites, for each cache, we've done this rate estimate that I've talked about earlier. And then over all the caches, I've taken the average of all these rates. And I've done this for each day nationally. And by putting this together, we get this graph where the x-axis is the days, spanning back from about 2.5 weeks ago. And the y-axis is the average estimated rate of the traffic itself. And so on this plot, you see all the major Republican candidates. So you might be thinking when you're looking at this graph, so this blue line right here is John McCain. This aqua line is Ron Paul. And all the other ones are sort of down here. And so you might be thinking, well, is it really the case that John McCain is that much more popular online than all the other candidates? And in reality, that's actually not the case because of this highlighted box right here on the McCain website. So what this is on the John McCain front page, there's a picture slideshow. And what the picture slideshow does is it basically makes an AJAX call, basically a call in the background. It basically polls the server every 30 or 60 seconds or something. And so if somebody leaves the John McCain website open in their browser, what it's going to do is it's going to constantly poll the server. And so you see sort of an inflated rate value for John McCain. So I'm going to coin that the McCain effect. So because of the McCain effect, and there's this underlying noise from this picture slideshow, we can't really compare the trend lines in absolute terms between John McCain and, say, Mitt Romney. But what we can do is we can try to look at the general trend of the McCain line because we have this underlying traffic. And so it's sort of, you can think about it sort of as a scaled representation of what John McCain's traffic really is. But I think we can take the shape of the line as accurate. And so you see Ron Paul has a relatively flat trend line right under McCain's. And he also exhibits a McCain effect on his website with the vicious political campaign donation gatherer that he is. He basically brags per minute about his exact donation amount. So this updates every minute. So that's why we also see an inflated number for John McCain. So comparing our previous graph to what Alexa actually sees, you actually do see that Ron Paul has an elevated hit rate compared to the other candidates. And the general shape of, say, the John McCain graph is about the same, except we have sort of an elevated level for him. And all the other candidates are sort of down here in this low-lying area. When we look toward the Democratic candidates, things get a little bit more interesting. So you see that right around the new year here, the blue line is Barack Obama, and he goes skyrocketing. He just shoots off the charts. This red line at the top is Hillary Clinton's web traffic nationally. And so she starts sort of with a high hit rate and then slowly drops off as the primary season approaches. And so when I first saw this graph, I thought, well, no way. I mean, there's no way that Barack Obama's web traffic could have, skyrocketed in order of magnitude in, about a week. But if we look at the trend lines shown by Alexa, this is actually sort of what's going on. Right around the new year, people have just been really interested in who this candidate is, sort of hitting the national scene, overtaking Hillary recently in Iowa. And so his traffic really has skyrocketed a lot in the past, say, 2 weeks. So we're getting, as validation, a relatively accurate measure, at least in terms of the trends of the candidates. So I don't actually know what's going on right now with the Hillary website. So our graph shows that Hillary's starting high and then going low, but the Alexa thing just graph just sort of shows it low and then sort of peaking a little bit. We're thinking that we're not exactly sure how to explain this honestly yet. We're thinking potentially in the period before the new year there was something like the McCain effect going on the Hillary Clinton website. The trend after the new year, about here, is relatively accurate in terms of the actual curve. So it sort of peaks up and then comes down. But we're really not sure exactly what's going on yet. So as we get more data in the next coming days, we'll see how that matches up well. We'll keep a closer eye on the actual particular things on the Hillary Clinton website. So this is one type of analysis we can do. We can basically take estimates for all the caches and put them together and come up with national trend lines. Since we can geolocate the IP address for all the DNS caches, we know approximately where the users are, so we can separate these rates by state and come up with trend lines per state and see how each state sort of affects this national trend line. Another type of analysis we can do is a regression, basically a multiple linear regression. So what I've done is I've taken the rates for all the basically five Democratic and 5 Republican candidates, and I've looked at 5 websites as predictor variables in the regression. And so the 5 predictor variables are Daily Kos, which is a liberal blog, as you might know, Michelle Malkin, which is a conservative blogger, New York Times, which is the Times website, Politico, as I talked about earlier, and The Economist's website. And so we're going to see how the traffic to the candidate website responds to these predictors. And so in this chart, the very intense colors, the really solid reds and the solid greens, show statistically significant correlations between the predictor variables and the response variables, whereas sort of the paler shades show weaker statistical significance. And green signifies a positive correlation, whereas the red signifies a negative correlation. So what's interesting in this? I'll leave most of the analysis to political scientists who can probably better explain or try to explain at least the effects here. But we can sort of look at the data and see what's going on. Michelle Malkin's website, a conservative blogger, basically isn't a good predictor. Her traffic is not a good predictor for traffic to other websites, whereas the liberal blog Daily Kos is, at least, it correlates much better to traffic to these candidate websites. Another thing that's interesting is Mitt Romney's predictors. And it seems like most of the other Republican candidates are well predicted by Daily Kos, New York Times, and The Economist, and some of them Politico. But it seems like Mitt Romney sort of has a disjoint set of predictors. Mitt Romney is well predicted by Michelle Malkin's website and Politico. I'm not exactly sure why that is. This is what the data is showing us. And we hope to pass this off to political scientists to see if they can make any kinds of better conclusions. What's also interesting is at the top for Barack Obama's website, none of the predictors are very good, are statistically significant for traffic to his website. And intuitively, the way you can think about this is that you saw his traffic skyrocket sort of after the new year, but it's doubtful that the traffic for any of these other blogs or mainstream media sites have skyrocketed in the same way that his traffic has. So none of these metrics are good predictors for his traffic. So this is another type of thing in terms of the granularity of the analysis that we can do. So essentially what we have is we have this huge data set where we can slice up basically however we want. We can look at, we can find rates for particular days. We can find rates for particular states. We can look at rates for, say, merge it with other data sets, look at urban versus rural areas. We can obviously track this over time. And so as we get more data, coming soon, we're going to have a website up with all the goods, hopefully with a lot of the trend lines nationally and by state as we get them, and also interesting results from the regressions that we're able to do in the next coming days. And I mean, we think that this is at least interesting for academics in terms of trying to analyze what's going on in the upcoming election cycle, but also potentially for market researchers or maybe for the campaigns even who are interested in knowing, what issues a particular candidate, the people who are interested in a particular candidate, what issues the users might also be interested in, or what kinds of media they're consuming. So we're going to be doing a lot of this analysis upcoming. This is sort of very preliminary results just to show the kinds of things that we can do with this data set. So this website is not yet live, but if you want to be informed of the domain, which we'll probably start tracking too once it goes live, when it goes live, shoot me an email, and I will email you once that happens. And yeah, I'd love to hear your comments. Thanks. Yeah.
Can you tell me how many of the sites you're tracking are SSL? I assume that contribute.com.
Yeah. So I don't know. I don't actually know exactly. So the question was how many of the sites that we're tracking are SSL. So I don't think contribute.hillary.com, at least the splash page is SSL'd. I'm not. So I'm actually, I don't think any of the ones that we're tracking are SSL'd.
So Alexa does not track SSL traffic. So
right.
If you have a good way of estimating SSL traffic, that's useful.
Yeah, that would be useful. I don't think we're doing that now, but that's definitely something that we can look into. Yeah. Oh, is there a mic? Do you want to? There was a question. Yeah. Oh.
So there's a bias with Alexa because it requires people to install a toolbar.
Right.
Have you thought about doing comparisons against other data, like trying to get Google Analytic data or other things like compete.com or things like that?
Yeah, that's certainly a direction we want to go to in terms of validating our data, because we don't even know if Alexa is right. I mean, they're probably the biggest and most well-known sort of traffic analyzer. That's where we can get information, but we actually don't know whether or not that data is actually good. So I think that's definitely a direction we want to go into. We want to try to find other data sets to compare this to try to see whether or not these trend lines and rates are actually accurate. Yeah, Avi.
Do you have any sense per domain name server how many users there are? Do you have a way of converting this hit rate into people, into like
Yeah,
numbers?
so it's definitely true, and that's definitely one of the biggest concerns we have, is that some DNS servers have a small number of users, and some DNS servers have a large number of users. But what we're looking at is basically still one DNS server. So the way that we're potentially trying to deal with that is we're tracking a lot of the major, like the big, really big sites, like the Googles and the Microsofts and the Amazons, and we can get rate estimates for those. And actually, for the regression that I showed you, I actually controlled for that. I basically added together all the rates of the large sites to try to differentiate between very popular or DNS servers with lots of users and DNS servers with few users. And I tried to control for that in the regression. I didn't show that to you, but that was in there. So we don't actually, so I think we could probably make some guesses based on the rates that we see. Maybe we can make estimates based on visits to Windows update sites, and if we know the percentage of Windows user, the average percentage of Windows users, maybe we can make a good guess about how big the DNS cache or the set of users are. Yeah, Tim. Oh, yeah, go ahead.
I
Sorry.
just have a technical question.
Sure.
For the regression, is it over time or over cache server?
So those are basically, it's not over time. So basically, each line of data is a particular cache server. And so basically, we've estimated a rate for each, basically, over the entire time period that we've been collecting, we have an aggregate rate for each cache domain pair.
I've actually got two quick questions.
Sure.
One is, do you have any sense if the people running these DNS servers know you're doing this, and if the amount of traffic is non-trivial, and obviously if this would scale to other people, if other people started doing it?
Uh-huh.
And then the other is, have you thought at all about the effect of embedding the Ron Paul site, for example? I'm pretty sure that little flash widget you can take and put on your own site, and then anybody who visits your own site will also make DNS queries against Ron Paul's, depending on how it's implemented.
Sure.
In many cases,
Yeah.
that'll be
Okay.
fine.
So, wait. Your first question was about. I should have just answered it.
About DNS administrators and whether they.
Right. So
use
we're basically splitting up all this work on Planet Lab. We've divided all the caches that we're looking at across about 200 Planet Lab machines over the U.S. And yes, we have been getting some people annoyed with the fact that, so to get a little bit more technical, they're annoyed because we're setting these authoritative queries for DNS caches that are not authoritative for that particular domain, and that's not necessarily standard. But the DNS protocol allows us to do that, and we're able to get this information this way. So we've had some complaints on Planet Lab that says, "Hey, cut it out." So we've blacklisted their servers, but over, say, 50,000 DNS caches, we've had, a handful, 5 maybe, people complaining that they're getting this errant traffic. So, so far it seems okay. Yeah. Another point is that it's sort of a security bug to sort of leave. There's no real good reason to have to leave these DNS servers open, these caches open to the public, but this is the way that a lot of people just possibly don't know that it's left open. So potentially these DNS servers could get closed at some point if they don't want this traffic to. And your second question about embedding. Yeah, I think that's possible. I haven't really thought about that, but that's a good point. And I think we could look into that and see. I mean, maybe potentially Ron Paul supporters have websites where they want to show. So you're imagining that a Ron Paul supporter will want to show the donations to Ron Paul on his or her website, and they do. And so that might also contribute to the elevated traffic even more. I mean, it'd be a McCain effect sort of amplified, potentially, even more than we would expect. Yeah, Cameron.
I had a quick question on the DNS snooping technique. I take it from your presentation that you actually have to know what you're looking for.
Right.
And so you're querying specific sites as opposed to sort of getting just general cache logs. Is that true?
Yeah, that's true. So we're explicitly targeting these 250 sites. So we can't sort of just do a dragnet search and say, here, just like send back the whole cache to. We basically have to keep polling the cache to try to check to see whether things have gone in and out of the cache, and then basically doing the math to find out exactly when it comes in and drops out of the cache. Yeah, Scott.
Have you done some work on finding out how representative the 50,000 DNS caches that you're using are? I mean, for instance, are you missing any big holes?
Yeah, that's a really good question. We haven't done any of that yet. That's certainly something we need to consider when actually making more authoritative sort of guesses about what we're seeing in the data. So yeah, we haven't done any of that yet, but we're planning on doing that soon. Yeah. Okay.
So the first is, I'm sure that these different sites have different timeouts for caches.
Right.
That seems like at the very least it would make it difficult to compare sites to each other. We can't hear you. Yeah.
Right. Okay. So the question is, different sites have different. So the way that DNS works in a little even more technical detail is that the sites, the owners of the particular sites will tell these caches how long to save these cache entries for before they time out, and then eventually the entry will drop out after that particular amount of time. So Hillary Clinton's website tells these DNS caches to remember the answer for 300 seconds, and then after 300 seconds, forget it. And then if somebody else hits it, come back to me and tell me again, just in case they want to move to different physical locations. This is one of the reasons why DNS is used. And there are other websites who make a different trade-off that say, hey, save this for half a day, and then after half a day, just keep answering with this answer for half a day, and after half a day, come back and get that answer, get potentially a new answer. And so I think the only difference that this makes is the number of samples we can get. So for a site with low TTLs, we can get lots and lots of samples of the out times to get a better estimate of the average out time. But when there are long TTLs, we can only get, say, one sample a day. But for the particular out time, we can still use the same analysis because once it does drop out of the cache, even for a site with a long time to live, basically we know that there are no hits during that time, and then we get a hit. So the analysis is the same. We just get fewer measurements.
Except that it could be like, it could be at night, for example, right? People might get less hits in certain periods of time.
Yeah.
And that sort of leads into another question, which is I don't know in terms of the DNS caches that you're polling, but it seems like this would be better on some caches than others, right? Very busy caches, for example, things might stay in there almost all the time.
Right.
Additionally, if you're polling institutional caches, for example, you're more likely to see certain types of behavior because people might be more willing to visit I don't know, certain sites from home or at work, and you're not looking at people, you're looking at the institutional cache. So.
Right. Yeah. So I mean, what we could do is so he was asking about the types of caches. If it's an institutional cache, you might get different trend lines, or so what we could potentially do is we haven't done yet is we can do a reverse lookup on the IP address of the actual DNS resolvers and maybe determine edu DNS. We could chunk up the data this way. I mean, we could look at the .com DNS caches. We could look at the .edu, the .orgs, and maybe there's a difference in the sites that people are visiting. Yeah. Any other questions? All right, thanks. And this should be a good lead into the third panel, which is civics in the clouds, right, David?
It is.
Okay.
And let's see. So it's nearly 10, and I think we're slated to go on at 10:30 to the meeting. Is that right? Yes. All right. Great.
Thanks.